All right, let's see if we can't put it into use. Again, on a problem like this, quadratics, I'm trying to solve a quadratic equation. I know it's quadratic because, as you can see, I have an exponent of 2. I would love to be able to solve for x. I can't because there's more than one variable. I would love to factor it, but two numbers that will multiply to give me 2x squared that will add to give me negative 6x do not exist, so I can't do that. Once I go from there, what I would need to do is say, can I complete the square? Well, when you factor out the leading coefficient and divide that by 2, you're going to get negative 3. Well, I don't really like dealing with fractions, so I would pick to use the quadratic formula. First thing I need to do is get it set equal to 0, and now I'm going to determine what a, b, and c are. So a is my quadratic coefficient, b is my linear coefficient, and then c, of course, is my constant. So I'll plug that in. We'll go nice and slow for you. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Again, you need to have this memorized. Okay, so when I plug into the quadratic formula, that's what it looks like. There's a lot of places to make mistakes. The first place is when you're trying to do the first step. After you've plugged in, you need to simplify your radicand. Okay, this is also called the discriminant, and we'll talk about that here in a little bit. But this is the information that we're talking about. Now, the common mistake in this is two things. One, to not put this in parentheses when you square it. Obviously, no matter what this number is, you're always going to get a positive number. A lot of times when you type in your calculator, you'll get something, and calculator will tell you it's one thing when you really wanted to do something else, but you didn't tell it the right way to do it. So what we'll get is we'll get 36. And then another place is a lot of times people get the signs wrong here. So, if one of these is negative, then you're really going to add this number to the other one. But since none of them are negative, we're going to subtract 8 from that all over 4. And then finishing up, we finally got to have our radicand now. It's the square root of 44, it looks like. So after you, oops, that's supposed to be a 4 down there. After you get to this point, what you would need to do is you would need to simplify your radical. So we would take the square root of 44 and say, well, is that a perfect square? And if it is, great. Oops, hold on. I added those things together. And I should have subtracted. Let's try it one more time. So this will be the square root, 28, I believe is what we get. That looks a little bit better. All right, so once you do that, what you're going to have to do is simplify your radical. So 28 is not a perfect square, but there are factors of 28 that are. 28 would really say it's 4 times 7. Again, the reason I picked those two is because 4 is a perfect square. I don't want to pick just random ones. I know 2 and 14 would work, but that's not going to help me because neither of those are perfect squares. So when you simplify your radical, it would look a little something like this. And then now what we need to do is we need to simplify our fraction. To simplify your fraction, what you're going to do is say, is there a common factor between this number, and this number? Ignore the one under the radical because it's not really a 7, it's the square root of 7. Now, so our last step in using the quadratic formula is if there's a common factor between those three, we need to simplify our fraction. There is a common factor of 2, so we'll divide all those by 2. So I get 3 plus or minus the square root of 7 all over 2. That is our answer. What you do need to realize is that is 2 solutions. If you need to get the decimal for some reason, you could take 3, add the square root of 7 to it, and divide by 2. 3 minus the square root of 7 and divide that by 2. But I would take an answer like that, but just realize it is 2 solutions because we are solving a quadratic equation.